So let us look at, we were looking at data in Excel last time. All right. So let me pull it up. See, come on. Locked for editing. Where is LA Heart? Do you see LA Heart anywhere in here? Nope. So why is it not letting me open up? That's not very, oh yeah, here it is. Okay, good. All right. Okay, good. So we are looking at this data, and I think last time we wanted to see this. Remember this? We talked about association between two categorical variables. All right. Okay. You shall see in the examples association, when we see association between categorical and numerical variables, or where explanatory is categorical, the response is numerical, and sometimes explanatory could be numerical and response could be categorical. Okay. All right. Now in here we are looking at a relationship between height and weight. All right. Tell me this, and height is given in inches and the weight is given in pounds. All right. Okay. For 200 individuals. Okay. Now here the variables are categorical or numerical, or one is categorical, other numerical. Yeah, tell me please. They're both numerical, right? And we are going to treat height as explanatory and weight as response. Okay. And what we are going to do is we are going to plot them, right? So what did we do? We made a scatter plot, right? Everybody clear? And this doesn't tell us much because we have all this part of the window which we don't need. So just a moment, I want to format axis. Okay, and it would not. Come on, let me format the axis. Okay. It just keeps me to the chart area. Yeah, here is axis, right? So I think we have heights. There is nobody shorter than, nobody shorter than 55 inches. So we'll change it that way, right? And here. And nobody lighter than 100 pounds, right? So let's change it to 100. Nobody heavier than 250, just for that window. So here we go. Let's get rid of these. All right, and I'm using Excel 2010 here. Okay, everybody fine? All right, so and you can put the labels here if you want. Okay, most of you have. Go ahead, Liam, sir.
We have to do this
In the assignment, you don't have to plot 200 data points in there. No, sir. Okay, you have to do some calculations. That's what I'm going to go over. Okay, did I answer your question? Good, thank you. And now I'm just telling you, just in case you are wondering that if I'm working on this kind of a thing, how do I do, how do I change these? So that's what I'm, just telling you, like axis title. It didn't give us the axis title here, horizontal title. And where did the horizontal title go? Axis. Display and axis title, but where do I write the title? That's not very good. I don't know why I dragged myself in that, and then what I even forgot where I was. First of all, my computer display gets messed up when I am in the, let's not worry about it. Okay, just put it here for the vertical title where I would have put weights in pounds. All right, and horizontal also somewhere it should be here, which it says what, height in inches. All right, Everybody clear? Good. So what kind of association do you see here? Positive, negative, none. It's positive. All right. Everybody clear? You know, it's positive. I mean, of course, you know, this person here is taller than this person here, but is lighter than that person. But mostly it shows like a rising pattern, and we'll talk more about those details soon. Carlos, everything good, sir?
Yes.
Okay, good. Everybody good? Okay. So now let's look at some other displays, like right here. Okay. This data that you see in here. Okay. Let me see if I view full screen. Oh, that doesn't look better at all, right? Okay, let's keep it like this, okay? So, this data in here, it talks about the student-faculty ratio at, you know, at a list of like 50 universities. I have posted the data on the website for you to look at, okay? And the alumni giving rate, like, you know, when you become alumni of a college, like we will be contacting you every now and then. If you have some spare, you know, money, can you give it to us? All right. Sometimes people give, sometimes they don't. Depends on how fondly they they remember their alma mater, right? Everybody clear? Okay. So here, a student-faculty ratio means that here they have fewer faculty per student, and here they have more faculty per student, and here is what percentage of alumni give back to them. Cindy, am I making sense? Cindy, am I making sense? Good. Okay, tell me, you have a positive association, negative association, or no association here?
The mean.
Let's see, Liam. Here, what's going on? Right. So what would you say? A negative association, right? Anna, is that fine? Good. All right. Let's look at more examples then. It's the same data. Now we have a different. We are looking at with. Again, I'm looking at the response of alumni giving rate on the percentage of classes with fewer than 20 people in them. Okay. Everybody clear? Okay. So that means what percentage of classes have a small size? That's what it is referring to. Frederick, is that good? Okay. Tell us this, Frederick. You see a positive association or negative? A positive association, right? Everybody clear? Okay. So, and then we are going to talk about the strength of the association. Now here is another data. All right. And this data shows us the square footage in a home and its selling price in hundreds of dollars. All right. So for example, you know, this home here has about 2,000 square feet of living area and is sold for approximately like little over or over $200,000, right? Everybody clear? That's what this means. So this is positive association, negative association, or none? Is positive, right? And again, like, how strong is that positive association? And we are going to look at only linear trend in our cases. Liam, go ahead, sir. Review, I'm sorry, what? Oh, how to do the percentages? Sure, I will do that, sir. I'll do that. Okay, very good. So, but everybody fine on this point, that if I'm looking at linear trend or any trend, in here we have a rising trend and you said it's a positive association. Later on we'll get more technical. Everybody good? Okay. Now let's look at one more example that we looked at the very first day, and here it is. Remember, we wanted to see if there is any association between the age of the billionaires and their worth, right? And we had the data for the year 2010. I'm sorry, I couldn't pull up it pull it up for 2011. I'll do that soon. In this case, what would you say? Do we see, you know, rising trend, I mean positive association, negative association, or almost no correlation, let me word, or zero correlation? Laura, you are about to answer that. Go ahead. Okay, that means if we talk about correlation, it will be zero, and I'm already going towards the word correlation. Okay, so that means if I try to create a line explaining the relationship between these two, the line will be almost what kind of a line? Horizontal line, positive slope, negative slope, what kind of line? Horizontal line. That sounds very good, right? Everybody clear? So X is what? Explanatory. T-A-R-Y or T-O-R-Y? I don't know.
No, T-O-R-Y.
Okay, thank you. All right, very kind. Just catching your attention, Anna. All right. Okay. And okay, Y is what? The response variable. Everybody fine? Okay. Now, mostly we will be working with the samples, so let's keep our symbols like this. By X bar, what do we mean? We mean what? Sorry, yeah, equals, but what does it mean symbolically? Just like, you know, we are keeping our vocab here. Yes, help. The mean, the sample mean of explanatory variable, right? Everybody fine? Okay. So when I'm writing Y bar, what does it mean? Sumin, help. What would you say it is? Mean of the? Go ahead, Sumin. The? Sumin. Yeah, you're Sumin, right? Okay. What do I mean? Mean of the response variables, right? And we are talking about samples here, right? Yeah, go ahead. You have question, Anna? Oh, I don't know. She was laughing. I thought she had a question for me. That's okay. Everybody good? Hiba, what do we mean by S sub X? What do we mean by that, Hiba? Yeah, what do we mean by that? Okay, Laura said, Laura, you had me explain this thing last time. Very good. Standard deviation of the X values, right? Everybody clear? And Hiba, what does S sub Y will mean then? I don't know. That's enough. Very good. Okay, I'm so glad you didn't feel offended. All right. Okay. Of the Y values. So let me bring another terminology here. Okay, that is R. What do we, what are we going to use R for? Is this, that we are going to use R for the strength of, a numerical measure of the strength of a linear association. Okay, everybody clear? Okay, and the way we will work with this is this, that is, when we say that we have positive linear association, what we will mean there is this, that is, the above average values of X will be accompanied with the above average value, values of the Y variables. Everybody fine? Okay, that the above average values will be accompanied with the above average values in the other variable, and when I have a negative association, you will see the reverse trend, that is, the above average values of X will be accompanied with the below average values of the Y. Okay, good. So see this here. So when we are looking at R, what we shall first do is this. We talked about above average values of X. So if I have an above average value of X, this quantity will be positive or negative? Somebody tell me? Positive. That's very good. If I have above average value of Y, this quantity will be positive or negative? Above average value of that will be positive as well, right? So when I have a positive association, mostly both these will be positive together or they will be negative together, and we will combine them by using what? This symbol. What is this symbol? Sum. Very good. Thank you so much. Okay. So that is this. Okay. And then we will go ahead and say sort of standardize them by doing what? By dividing by their corresponding standard deviation. And if we are looking at a sample, then we will divide the sum of the products of the standardized values by n minus 1. What is n? Go ahead, Sir Liam. Say that again. Okay, I'm going to use it right in a few seconds. Okay, we are going to use it right in a few seconds. Am I clear? In a few seconds. Okay, I promise. And I'm on record, so I have to keep my promise, right? Okay, good. So this is the formula, and that's how you use it. And Liam asked a very question, when I'm going to use it. Like n is the number of unit subjects or whatever that you have in your data. All right. Okay. So let's use it right now. All right. Everybody clear? Okay. Carlos, everything good, sir?
Yes.
Good. Thank you so much. Okay. So let me get this data. Okay. So see, this data here is a data, okay, showing like, first of all, how many values do we have in this data here? We have 7 pairs of values, right? And what it does, Hiba, is this, that if the cost of meal, say in that restaurant, was $83.57 for this service, how much did the customer leave as tip? How much? $15, right? Everybody clear? Here, if the cost was this, the tip was left as this. Everybody clear? Okay, Anna, making sense? It's a data. I mean, it's a data that, okay? Makes sense? Everybody good? Okay, good. Very good. All right. So
You found like the theoretical slope of these?
we will find the theoretical slope very quickly.
What would that give you? Anything? Would that give you any kind of information?
We will see if it gives us any kind of information. All right. Yeah, we are going to, of course it will, if we do this, if we plot this data, okay, and we do the line of best fit that we are going to do, all right, we'll see how does correlation play a role in that, responding to Liam's question. All right. Okay. Okay, good. So we have these guys, right? So let's go ahead and plot them. Okay, so when we plot them, what do you see? Positive association or negative association? Help? A positive association, right? Okay, we will play with this in a few minutes. Okay, so, and we are going to do what? We are going to use this formula for calculating the correlation, right? Everybody clear? Okay, good. So let's go in here, and first we need what? First we need the average for the x values and the average for the y values, right? Everybody fine? Okay, so here, does everybody know how to compute averages? How do I compute the average of these values? Help? Divide by 7, right? And we know that already, so we'll let the computer do that, right? 7 actually, see the top number is the label, right? But thank you. Oh, what was that? I forgot. 140.56 point what? I'll get it again for you. I know. Okay, that's $156.14, right? And so here, $156.14. Okay, okay, all right. I am broadcasting myself that I don't know much in Excel, but that's okay. All right. Now I'm computing the standard deviation. Okay. Everybody clear? A standard deviation of this sample, and we saw how to compute that. So we'll let the calculator compute it, or the computer compute it. Okay. And so we are looking at sample standard deviation, and we want it for all these guys, right? So how much is the standard deviation? Well, $83 and how many cents? 45 cents, right? Okay. Everybody clear? So we will say the X mean equals that, right? Everybody good? And the Y mean equals that, right? Are we good? So, oh, no, it's not Y mean. I don't know what I was thinking. Okay, X STDV of the X values is that, right? Everybody fine? Yeah, we can figure it out in our calculator. And remember, I have posted a video how to do that in your calculator, and we did that in class also, right? Okay, and I'll gladly answer questions on that later on. Okay, all right. So Vanessa, what would we do here? We would compute the mean of the who? Vanessa, the Y values, right? Okay, and what do I hit for computing the mean? Laura, average, right? Okay, good. So now this is the average tip in this case, Chad. We were talking, is the average of all the tips that we see in there, okay? All right. Okay, Anna, are you okay?
No, I'm lost.
Why? Because you were talking to him. You're not listening to me. 1 second,
No, I'm saying, why aren't you using the formula?
Why am I not using the formula to compute the mean?
Right. No, not to compute the mean, because you add them all together and then divide it by the...
Right. So before I use this formula, I need all these ingredients, and that's what I'm getting. All right. Okay, and you were just and let this argument between Anna and me go on the YouTube, right? It's okay. Go ahead, Hiba, ask your question, please.
How do you, calculate the standard?
Okay. Without computing, you can compute it by your calculator, or compute it according to the formula the way we did like 2 weeks ago. All right? I'll show it. I'll show it to you again, I promise. But right now, just give me a pass on that. All right? Okay? Good. All right, Henry? Okay, thank you. So Henry and Hiba, both of them gave me a pass on that. And Anna is going to have a little more patience for me, right? 30. Thank you, Anna. You're very kind. Okay. All right. So here is what? Y mean. Okay. Equals what? Equals this, right? Okay, Henry. So far, so good, sir. Okay. And you're going to let me calculate the standard deviation using Excel, and I promise I'll review the manual calculation for you soon. Okay. All right. So standard deviation sample. Of who? Of these guys. Be careful. Okay, so that's what? $22.87, right? Okay, and who is this? Is the standard deviation of Y values. Okay. Anybody confused on what we have done? We have computed these numerical summaries, right? Okay, by automating the calculations. Everybody good so far? Okay, good. All right. So, if I wanted, see.
Hold on, you just got the standard deviation for the Y value.
Yes, ma'am. Yes. So go ahead and.
I thought that was with the formula.
So sorry, that was what?
I thought that you got that with, like that. You get that with the formula.
The standard deviation, you can get that with the formula as well, but I did not use the formula. I just used the computer. Okay, but I demonstrated how to use the formula, in which I'm going to do again. All right, see, Hiba and Henry, they've already asked me to do that, and I'm going to do that. All right, okay, very good. Go ahead, question? No? Liam, sir. I'm going to do that if I'm allowed to proceed. All right, very good. Okay, so here, see, this is the cell for who? This X value, right? Am I clear? Okay. Tell me this. This particular order has a below average value or above average value? Below, because the average of the values for meals was what, like about $156, right? Everybody clear? And the value of tip is below average tip or above average? Below, right? So anyways, I'm just writing. So here, then I'm going to subtract the mean here. How much is the mean? 1. All right. So it's below average. So the difference came out to be what? To be negative. All right, Taylor, am I making sense? Liam, sir, again, go ahead.
So what did you just subtract from?
I subtracted from $83.57, okay, the mean of the X values, right? See, I'm subtracting from the value of the meal, all right, okay, the mean of the meals. And you're only smiling, Liam. Tell me, it's a happy sign or not a happy sign? Huh? I can't hear you. Say that again. It's confusing? All right. I did this. I took 83.57, right? Minus the mean, okay? All right. And it tells me what? That this is, this is $72.57 below the mean, right? Okay. This value is above the mean or below the mean?
That's
Above mean, okay? Tell me just roundabout, how much above? How many dollars above? This one. $8 above, right? And so it should be, let's do this here, see? 1 sec. Okay. Yes, you guessed it right, Liam. It's about $7.50 above the mean, right? Isn't it? Make sense? Okay. Then here, this value is below mean, and of course this is negative below. Exactly, and we did it pretty fast, didn't we, right? Okay. All right.
So you're subtracting.
Here I'm subtracting.
By the mean. Okay.
Ma'am, yes. Okay. Now we are going to do the same thing for the tip. All right. Okay. Everybody clear?
Oh, okay.
Okay. So here we are taking the tip. And what should I subtract from here? Henry, please help. Henry?
32.
Okay, you go ahead, Anna. You can become Henry. Go ahead. 57. You're talking to me. That's honorable enough to me. All right. Okay. Good. All right. And then we are going to do this for all the tip values, right? Okay. All right. So here, let me delete this. Everybody clear? Below average X value with below average Y value, above average with above average. Sometimes it will be opposite signs. We'll combine them and you will see lessons learned from that. But right now we are happy with these guys. Everybody good? George and Chad, do I have your attention here? Attention means do I have your understanding here, right?
Yes.
Okay, very good. Carlos, everything. Mark, I can't see you. Everything good, Mark? Okay, good. Thanks. Everybody fine? Good. Makes sense? Okay. So now what we will do is that, what does this mean? We are going to, 1 second, here. We are going to multiply them together, then add them together, right? Everybody clear? Okay. So here we go. So we have this, right? And what we are going to do now? Multiply by this deviation from the tip. So I get that. What happened?
I got it.
I know you would get it, right? And then I add them together. This is,
You should teach a course in Excel.
huh?
You should teach an Excel course.
No, I barely know any Excel. You can see, I struggle through that, right? Everybody good? So this is what we have, right? Okay. Very good. Taylor approved it, right? Everybody clear? So look here. What did we find for this value then? This is the value that we just found on the in X. No, that's not going to help. Okay.
What does the sigma stand for again?
Sigma, what does it stand for? Anna, you're right next door. Tell us, what does it stand for? The sum. Go ahead, Liam.
So you basically just multiply.
Yeah, I basically just did. Go ahead.
So
I multiplied this value with this value, right?
So you multiply the x mean by the y mean.
I multiply x minus x mean with the y minus y mean. All right.
Yeah,
So
you multiply the negative 7257 by negative 17.
exactly, sir.
and what does that give you?
That gives us this. Okay.
So that's the top.
That's the standard deviation of the y.
It's not a standard deviation. Is the sum of the product of the deviations from the means, right? Okay. So
Can you go back to the other screen?
I will go back to the other screen. Go ahead.
I have a question.
Ask me a question.
Okay. You're gonna do like the standard deviation. That's the thing that I don't get. How do you get the 22.87?
I will show it to you. How do I get that? Okay, I promised I'll show it to you. All right. See, Heba and Henry are patient, but okay. All right. Everybody clear? Okay. So who are these values here? Let me take these values up there so that I'm not switching back and forth. All right. Okay. Good. So here we are. All right. Good. So tell me this. So here we have sum equals how much? Excuse me. Oh no, I didn't want you. Sorry. 11,326 point how much? 34 cents, right? How many values did we have in our data? 7 or 8? Liam, tell me. 7. There were 7 since we are looking at sample. We'll go for one lower. Was the standard deviation of the x values 83 point how much? 45, right? We did that, didn't we? Right, Chachad, am I good?
What's 7 minus 1? Where did you get that from?
Oh, that's here, right here.
Where's the 7?
The end is
Oh, 7 is this I
7 number of values. Okay.
sir. Okay. Then what we have? We have times, and then what we got? 22.87. Thank you so much. Everybody fine? Okay.
So
that's
what happens to the x?
What happens to the?
156 and 32.
Oh, that was accommodated right here. See this here?
Oh, that's the combination for that.
All right, that's accommodated right there. Yes. Okay. And let's see what the correlation is between these two values. What is the value of correlation here? 0.989, etc., etc., which is approximately how much? If we go to
1.
oh, very good. He's saying actually 1 is the correlation when the points are perfectly on a straight line of a positive slope. All right. So here it is 0.99. Oh, sorry. 99. You could, okay. All right.
And
Equation of line of best fit. And you said the word best fit. What do you mean by that? Tell me. That is the line that describes this relationship the best, right?
pretty self-evident.
Pretty self-evident. Very good. Don't hear that much in math class, right? Okay. And it is also called the least square regression line, right? Okay. Best fit. All right. Now, when I'm writing equation of a line, then in that case, Sam, typically I write what? Slope and the y-intercept, right? Am I making sense? Right? Okay. So what we have is, by B, I am denoting the slope, all right, which is a little different from, the things that you are used to. But anyways, this is the equation of line of best fit. Anna, what is that strange?
yeah, that
the house over
why. What's that for?
All right, let me erase it. Happy now?
Yes.
All right, okay. But I'll put that hat above y, all right? Okay, because sometimes I put a hat too, so y is also entitled to that. See this here? Okay?
Okay.
All right?
That's
Just called hat. All right?
cute then.
Okay? All right. So you don't mind it now, right?
I don't.
Okay, thank you for letting me do that. All right? Okay. So where are we?
I can write it down.
Where is it? Here, go. Okay. So which letter shows the slope here? Laura, very quickly. The slope is B, right? Makes sense? So B is, now I'm not deriving this formula for you, all right?
Why is it not mx plus b?
Why is it not? We can write it mx plus b if you want, all right? It's the same thing. I'm just giving it to you in the notations that the most of packages will give it to you. But mx plus b is the same thing and b is not the slope there, right? So what is the slope? Slope is the coefficient of x, right, Chad? Who is coefficient of x in here?
B.
B, right? So we just wrote it in a different form. Go ahead. Just like when you go to London, you drive on the left, right, don't you? Okay, okay. Go ahead, Anna.
Oh no, I didn't know.
Okay. So B is given by R times the standard deviation of the Y values divided by the standard deviation of who? The X values. Okay. Just and this will be printed on your test. All right. That this way of computing the value of B. Go ahead, Liam.
So you're going to divide, if you went back to the same problem, you're going to divide 2287 by 8345.
Very good. You're so kind. Thank you, Liam. Okay. All right. So let's do that. In this example, give us the numbers again, please, Liam. That was 0.99. R was 0.99. Heba, you look tense on this. R is 0.99, right? We just did it a while ago, right? Right? Okay. And then Liam, please give us those values again. You're very kind to have said it.
Would that go into parentheses or no?
It doesn't matter. If you are using it in your calculator, there we have to put parentheses, right? So what did you say? 22 point? I forgot. 87 divided by 83.5. Just 5 or any more? 45. Thank you, sir.
So that other formula found the slope of the line of best fit. Now we're finding the equation of the line of best fit.
Now we're going to write the equation of the line of best fit. So how much is the slope? The slope is approximately this much, right? Everybody clear? So this is our slope. Okay. And let's take, Liam, I'm going to do standard deviations in a moment. You help me on this. What was the Y mean, Liam? I don't have it on the screen here yet. Could you recall that for me?
The 2287?
The mean of the tips, right?
Oh, the mean?
Uh-huh.
You want the Y?
Yes, sir.
3257.
32.57. Very good. Okay. Somebody, anybody, what is B? I have to.
So what are you finding now?
I'm finding this value now because for line I need the slope and the y-intercept, right? Okay. So I'm finding the y-intercept now.
So the 0.2713
Is B, that's the slope, okay? That's the slope of the line B, yes. Okay. All right. And who is the x mean then? Somebody, anybody recall for me? Yeah, what is that? I mean, I have it in my notes too if you don't want to help me. 156 point, how much? Say it again. 14 you said, or? 14. Yes, you said 14. I just was hard on hearing there. Okay, very good. So what's that? Negative 9.980 is good. All right. Now, so the thing is this, that is negative 9.79 plus how much? 0.2713. All right. Say that once again.
Yeah, why did you subtract it? That's one.
Why did I subtract it?
Yeah, because
Because
yeah, like the normal equation.
so we have, this is our line of best fit, right? Everybody clear? and we had already graphed it, right? Okay. All right. Makes sense. Okay, there we go. And if we graph this line, and you all know how to graph a line, but I'll graph it again. But right now, let me just see this here. And first make it a little bolder. Everybody fine? So this is our line of best fit, right? And what is the equation of this line? We already have here negative. Right. Very good. Okay. Now, notice this here. If you stretch it to this side, it goes to negative, right? Notice this y-intercept is negative $9.08. You cannot apply it here, that you can't go. I mean, the restaurant doesn't behave like this, that I go in there, I don't order anything, and the tip is negative $9.80. You know, right? Waitress is not going to give me $10 to me for not ordering anything, right? So as I said, in mathematical sense, I mean, don't say that I went there and I was such a menace. They said, well, take $10 from me and go away, right? I am going to do that because that's going to hound me forever. I'm going to do that in a moment, okay? Just a second. Okay.
Just take the highest x value minus the lowest x value for the standard deviation of the x, and then the same for y.
No, you forgot it as well. Somebody recall, what is formula for sample standard deviation? Yeah, what's the formula for sample standard deviation? We did this. Take the square root of what? The sum of, right? Right. X minus who? Right? Everybody clear? That's how we computed the sample standard deviation of X, right? Didn't we? Everybody clear? Yes, sir.
So you just plug it in?
You can plug it in, all right?
So you're subtracting the mean minus...
Okay, so let me take the example for you. 1 second. Okay? Okay. So this is how you do that, right? Okay. So now say we are doing it manually for these guys here. Okay. All right. And I have to compute the standard deviation for these, right? Everybody clear? Okay. So what I will do, I will take these values minus what? Their mean, right? So x minus x mean. Henry, am I clear? I'm doing it for you the way you wanted, right? Isn't that what you had wanted? You just showed, Hiba. You wanted to see how to compute it, right? So I got the x values, right? And then I'm going to do what? You know, take every x value, right? And subtract the x mean. The mean of these values. How much is the mean of these values? Somebody?
It was like
156.14. We did that a short while ago, right? So this is what we get. All right. Everybody clear? Hiba and Henry, any objection to doing it quickly? I mean, you can subtract them one by one if you want to, right? Okay. Hiba, do I have go ahead?
So that gives you the standard deviation of x.
Not yet, no. It just gives me all the deviation of the x values from where the mean, right? Makes sense, Liam?
So then how do you...
I'm going to go further. So what was the next thing that I needed? I have to square these all, right? Am I clear? So let's square these all. Okay, so x minus x mean square. Let me increase the font size here for you. Everybody clear? So I'm going to square them, okay? So if I square this quantity, square it in your calculator and see if it matches with what I'm going to do. So here we squared this, right? Liam, am I clear?
So
Uh-huh.
basically
Uh-huh.
then you
Square that. Right, you square this, yeah.
then down gives you
So first of all, you square it for all of these values, right? Makes sense? Everybody clear? Okay, Carlos, is that good?
So wait.
Wait,
Square each value, right?
Uh-huh. Each value, yes, ma'am. Okay.
and then after that you divide by 46 for all of them.
Right, I'm going to do that for all of them, but first I will add them together, all right? Okay. So this is the sum. So let's take our sum down here. So how do we get the standard deviation then? I take this and then here what I have this value in here, right? Makes sense? How many did I have in my sample? How many 7. Thank you, Taylor. Okay, so there we go. And isn't that what standard deviation was for these guys? Okay, do I have anything different, or it was the standard deviation? Just a second, let's look.
This is pretty cool. It's a scientific workplace.
Yeah, it is cool. Yeah, it is cool. And okay, and I'll show you how to get that. So first of all, everybody clear? That's how we do it. And Liam, if you have, I mean, you will have the formula on the, on the test, but if you look into the course contents, see this here? Everybody please give me a second. If you did this, if you look at this video that I have created for you, it tells you how to compute the mean and standard deviation and everything by using your calculator, right? Henry, have I answered your question? Doing by hand and by your calculator, right? Everybody good? And Chad, if you want this scientific notebook or workplace, just Google it. It'll tell you where to get it from. It's not very expensive if you want a student version, all right? It's okay. No, well, I think you can download it for free for 1 month, I mean, when you are doing calculations. So anyways, everybody good so far? Okay. So